How are we going to make a better society is by people who are adaptive, because society is only getting faster. It will never slow down. And if you slow down, you lose.
Are you ready? All right, let's go.
Manufacturing is sexy. Sounds crazy? Just wait. I'm Z Holly, host of The Art of Manufacturing. Your behind-the-scenes look at how people who make stuff are trying to make it in their industries. If you've ever wondered how to build a brand, a business, or just a better mousetrap, tune in and enjoy. Happy Robotics Week. Last week's episode seemed to strike a chord with so many of you. Thanks for your messages. Chris Wilson's story of redemption from a life sentence to successful entrepreneurship was so inspiring to me. And if you liked it too, you might also check out Kabira Stokes from Season 1. She puts returning citizens to work recycling electronic waste and has some surprising stories. And I have some great news. Her company was recently acquired by Homeboy Industries. So a big congratulations to Kabira. This week, we're doing a 180, going from artisanal to automated, from urban decay to Silicon Valley. It's just as thought-provoking as last week, but for much different reasons. Technology has certainly been changing the way we communicate, how we shop, how we date, how we get around, and it's changing manufacturing too. Silicon Valley has gotten a reputation of being a, quote, disruptor, and depending on who you are or what part of the country you live in, that term is either a compliment or an insult. This week's guest pokes at that hornet's nest. I visited Nick Pinkston at his startup Plethora, an automated factory right in the middle of San Francisco. Like many of you, I'm incredibly curious about the potential impacts of automation on the future of jobs in manufacturing. Not everyone is fond of automation, but many will tell you it's inevitable, while yet others will argue it's saving production in America. Nick, as someone who grew up in Pittsburgh, has his own unique perspectives on manufacturing, capitalism, and education, and they might not be popular with everyone. Also, Nick is regarded as one of the key connectors in the hardware industry, and I was eager to hear his advice from entrepreneurs thinking about starting a hardware company. In honor of Robotics Week, we nerd out about that and a whole lot more on this week's episode of The Art of Manufacturing.
So I'm Nick Pinkston, the CEO and founder of Plethora, and we essentially make prototypes and short-run parts for companies that are making new products. And we do that by essentially making a new kind of factory that can like automatically take a 3D file and turn it into all the sort of commands that the machines need to make it, which is normally done by a lot of people. This is now done by computers. So we've made it so a customer can sort of just like submit a part and it just happens and comes out. So how can you make manufacturing like a push button exercise essentially?
And what's the actual user experience in that case then? Let's say if I'm who would be your typical customer?
Sure. So you're an R&D like mechanical engineer. You're designing a new product and you need to like make a prototype to test it out. So the software that you design in, it might be SolidWorks or Autodesk Inventor. There's a few different ones. We plug into that software, and so as you're designing, we are analyzing your part in real time to say, this isn't possible to make, or that's going to be expensive, and then we'll give you a real time price as well. So it knows kind of everything about how that process will happen, and then you just hit buy, and then it goes to our factory and make it. In a couple days you'll have it, and pretty soon it'll be like the same day. Yeah.
In looking into the future, what do you see that factory of the future looking like?
Yeah. I mean, I think that a lot of the things that software has already done are going to end up in the physical world. So the great thing about software is there's no time or cost to kind of deploy, really. So, you can write code, hit enter, and it happens. So the future of the factory to me looks like the factory is almost like a cloud server. It just like exists. You don't have to think about it. Like today, you have to visit the factory if you want to make anything. You have to talk to people on the phone and ask them questions in English. It's crazy. And so like, how can you make a factory where you just like send it the thing you want and it just does it,
Mm-hmm.
And that's where we're spending months to get a prototype or something like this right now. Software can do this in a day. Like it's really hard to have like a hardware, say hackathon where anything meaningful comes out of it at the end because it's so long to do any hardware development. So the real future of this factory is like making it so it's just instantaneous to produce these things and at very low cost.
It's interesting though. Like when I went to engineering school, we learned about how to design for manufacturing, and so you would presumably not make a lot of the mistakes. So are you?
You'd be surprised. Yeah, I mean, it's funny. Like the big name brand companies, that we work for, they hire a lot of engineers who are junior people from college, and they definitely do not get that. And actually, engineering programs today, it was funny. I was looking at a mechanical design book the other day, and there was one page on manufacturability. Like you'd think that would at least be a chapter, and this book was about like designing machine systems. And it's like, that's the whole point, is how do you make this thing and how do you do tolerances? And that's the stuff.
And actually, it's true. It was an elective. So I did not have to take that design for manufacturing class. So, good point.
It's funny. Yeah, it's crazy to me. And I think that's because that, people are going to go into some, they're going to go to GE or something, and GE has the GE way of doing that. And there's all these constraints that GE alone has, and it's on the job training to them. Mm-hmm. And so this is why you have to like kind of know your manufacturer a lot. So you know exactly the machines they have and what their capabilities are. What we've done is we basically encoded those capabilities into our software. So you know exactly what it is. So even if you're an experienced engineer, you don't know every drill bit we have, and you don't know the exact process we're going to use to make it and all of this. We tell you that. It's very transparent and instant. So as you're designing, you can figure that out. So you'd be surprised how much manufacturability is like very custom to the factory itself.
So that's your vision. Where are you now? So what's the user experience for me, let's say, if I'm...
That exists now, yeah. Mm-hmm. So basically, we have these plugins that exist, and our customers are ordering from the plugins. So you can download it and instantly have it working, and then you can hit buy, and it goes to our factory, and it's made. So that's the experience for just CNC machining. So that's milling and turning. And then really, it's like going into all these other different processes.
Now, how is that different from... There's all sorts of companies like Fictive and what's the one in the East... that they have the whole network of CNC machinists. Yeah, so there's the network model, and then there's the sort of more like vertical model that we've taken. Mm-hmm. So our opinion is basically that so my previous company, CloudFab, we had a network too. And when you're doing 3D printing and kind of basic stuff, it's a lot easier to do that because there's not a lot of information you need to relay between it. And there's not a lot of operational, or sort of like, there's not a lot you can do to make the machines better. Like you get the 3D printers, they already program themselves, and you just kind of keep them running in operational excellence. With what we do now with traditional processes, you have to like completely change how the machines are actually working. And how you're programming them to make it a change. So those distributed models are still relying on the traditional job shops that work in the traditional way at traditional speeds and have traditional human-based communication. So these things are almost like directories that tell you where these are and help you sort of automatically quote something, for instance, but they don't actually change the fundamentals of how manufacturing is done. Mm-hmm. I wanted to change like the very deep nature of it. So we go from directly inside of CAD all the way to the aluminum and the machines and the code on the floor, because that's how you fully optimize a system. And how you get the best sort of user experience is who the customer is. They know we are Plethora. You can talk to a person on our floor if something's going wrong directly, and there's no intermediaries to like remove that information. So it's really about speed and performance, because that's what people buy on in the R&D market. It's like, how do I get like the best part possible really, really fast? And so that's why we have this full vertical model. It does appeal to the senses, though, the idea of the distributed model where it's basically in the cloud. You can turn it on like water or the light switch, right? How do you deal with demand, and do you have to worry about that?
The scalability, like people, investors, when we first talk to them, like, oh, wow, isn't this very capital intensive? And it's actually not. The R&D market, because we remove all the setup cost from this, which is like 90% of the cost of a part, we have these good margins where like the machines actually are only like a couple percent of the cost of a part for us. So it doesn't matter. And I can get new machines on the floor in like a month. So like, as you see it, you just kind of plan for that, And so it really doesn't matter with the high margins. The machines aren't the big cost. It's the human cost of programming that equipment.
The immediate assumption that people have is, okay, you're replacing the skilled machinist. You're replacing jobs. And so again, automation, killing jobs. Tell me about that. I'm sure you're asking that question a lot.
Yeah. I mean, I think that we're definitely going to see a shift in how people go. I mean, if you're just loading parts into machines, like that job is more at risk than if you're programming that machine. And if you're programming the really hard stuff on the machine, then that's even less at risk. You've seen already in the economy, like a lot of that commodity work has already moved overseas because there's really no high value add in it. Like electronics assembly or something is just so commodity that who wants to have a company like that in the US anymore. And so they don't, and they get more and more specialized working on, as we progress in society and as an economy, it gets richer and richer. And that specialization is how you have better engineering, right? Like you have really high performance specialization, and that requires specialized companies to serve them.
Well, I definitely want to get back to that point too, of sort of what does this mean for the future? For a second, I want to jump back, and we talked about CloudFab a little bit. Tell me a little bit about what inspired Plethora and how you got to this concept.
Yeah, sure. I mean, I think that, part of why I love factories is because I grew up in factory land. So, my family, we're from a place called Newcastle, Pennsylvania, which is an old sort of dying mill town. And my whole family was in manufacturing. So my grandfather was a prototype machinist at Oldsmobile. My dad was a production manager. My uncle had a tool and die company outside of Detroit. So the whole family was in this. And so I was in factories in and out from a very young age, and I learned how to make things also, and was really into trains and steel and all these things. I was just obsessed with that stuff growing up. And when I got to college, I read a book actually by Neil Gershenfeld called Fab. This was in 2006, I guess. Actually, it came out in 5, but I read it in 6. And I was like, oh, digital manufacturing. It really hadn't occurred to me until then, because I was just all hand tools, And so then I was obsessed with this idea. And so after I got out of college, I made a hackerspace called Hack Pittsburgh to give people this democratized access. So I took my workshop and made it a subscription workshop, and we got that kind of to break even. And then I got to know all these manufacturers who would donate equipment to us and were interested that something was new manufacturing in Pittsburgh. And then I was like, oh, let's connect people to them. And so that's when I started CloudFab, which the idea was, you automatically price things and have a network of these 3D printing shops. And then, you just kind of grow that. And it really makes it so you don't have to interact with a bunch of people on the phone, yada, yada, the standard internet stuff. But what I found is when you go to those factories, you're like, wow, these are really run inefficiently, and it's super old school. And I had to learn a lot of math for CloudFab, and that math sort of was for quoting the parts. But then later I was like, oh, we can just go further. We don't just want to limit math to quoting. We can do the entire process automatically. And so I began looking into how to do that. And at that point, sort of like I said, I was like, okay, we're going to need a factory, because all the old guys who own the factories are not going to do it. I asked them, and they wouldn't do it. They're sort of very skeptical of this. They're very much show me kind of people largely. And so that was okay, I sold that company, moved to San Francisco, did some research, raised money, started Plethora, got a little factory going. And then, here we are with a bigger factory going.
So how would you compare the Bay Area to Pittsburgh? What's that like? I
mean, the thing with Pittsburgh is that I honestly, I feel like I still sometimes feel this way of kind of being this outsider, of in Pittsburgh, the insiders are, it's a very much kind of working class, sports, kind of a very anti-intellectual culture, honestly. And I feel like I don't really fit in Pittsburgh very well. And also not really an ambitious culture. People who were starting businesses, it was you want to start a business? And even the people who were funding it, the biggest funder actually, they're a government institution. And so I don't feel like they have the same kind of pressures. And so when I never went to San Francisco until maybe a year or so before I moved, and I went to South by Southwest, and that to me was now I'm oh man, South by Southwest, I wouldn't go there. But now at that point, it was whoa, there's this whole tech community, and Pittsburgh, it was 100 people, and I ran all the events, so I knew all those 100 people, who did that stuff there. And then coming to San Francisco after South by was what, the entire neighborhood is talking about this stuff, it's crazy. And then meeting people who were talking about crazy futuristic things that I would talk about with a couple friends in Pittsburgh who would understand it, but now it's everyone understands it here. And there's just a lot more people believe in optimism about the future that I just think it's too conservative in Pittsburgh. People don't actually care about it, and that's, I think, a fundamental problem.
Well, and they feel a very different reality too, and I wonder, do we go here? The differences in cultures and understanding. How do you make the abundance actually reach all the different corners of the country and the world?
I know. And it's super interesting, right? I mean, people are already migrating to cities from the rural area for these opportunities. And yeah, what are the opportunities? I mean, I think standard economics actually has some to say about this as far as Google and Facebook and all those guys are putting offices in Pittsburgh now because there are good schools and it's way not cheap. It's way not expensive compared to here. So, you can buy a house in Pittsburgh for like $100,000.
Which is
my
crazy.
house in Pittsburgh was less than $100,000. It's crazy, right? Yeah. And so it's very easy to have like a very good upper middle class existence being an entry level engineer in Pittsburgh. That is not true as much here, maybe, where you're like kind of in a small apartment without parking and, all the rest.
Well, and that's a crazy thing. We're in the middle of Dogpatch. Tell us about Dogpatch.
Yeah, I mean, the Dogpatch district has transformed a lot. It's like historically the industrial district of San Francisco on the bay side of the city. And over the past 5 years, it's gone from kind of sleepy, there's not really a lot of factories and there's not really a lot of anything else, to there's all these like nice restaurants and wine shops and everything else. So it's definitely gentrifying. I believe this is now the highest rent neighborhood in the city.
Really?
Interestingly enough. Yeah, we are on just the edge of it. So we're right next to Bayview, and I think even our zip code is Bayview, and that is a much more depressed area, which is like kind of historically there was a huge shipyard. Yeah, and this factory, we can have it here, I think, because the rent is super cheap because the zoning is still favorable.
Oh boy, that's a whole issue. Zoning.
God, San Francisco and zoning. How could that be an issue?
Yeah, I mean, any large city. I mean, Los Angeles.
Oh, I'm joking. It's horrible here for zoning.
Yeah, no, totally. Yeah. No, it's and it's what's scary is you also have the pressures for housing, and so there's pressures for the conversion, and of course, any developer is going to want their spot zoning for housing.
Completely, yeah. And I can't say I argue with them. Like if this wasn't here and we couldn't get any industrial space, we would be in South San Francisco or Oakland, something like this, if we couldn't get space. And it's still like, we think about having our headquarters where, we have engineers right next to the machines because we have to do that to develop software for them. So we have to have this space. The next one we have might be very expensive, and we'll have to see. So far, it's super cheap being right here.
Well, you're very lucky. Wow. So do you have any thoughts on policies that would help revitalize the industrial sector in that vision that you have?
You mean in locally or nationally?
Either way. I mean, what because there's definitely some thought processes of, well, we just need to move forward and try to change zoning, whatever, or we need to protect as much as possible so that we can protect the industrial areas. And I don't think that either one is exactly right.
Yeah, no, I'm with you. And like, I'm not a huge proponent of trying to maintain industrial zones in cities, actually. I actually think that transit is the bigger issue. So if people could actually have efficient transit, if BART, the local subway system, would actually go further south and wasn't blocked by all the South Bay communities, then you could actually take a subway from 24th Street to, San Carlos or whatever and go to a factory in 20 to 30 minutes, and that would be fine. And now it takes like hours unless you're right on the stop and everything else. So it's like just impossible. So to me, the Bay Area, I really wish we had a regional authority that had like San Jose, Oakland, maybe even Marin or whatever, and San Francisco all together so we could get our transit in order, because
you do have some interesting political. Well, we don't want to go too political, but like some people might think of it as a little bit of a paradox. So tell us a little bit about what your philosophy that drives your political views.
Oh man, yeah. I mean, it's funny. I mean, I think that my personal views are hard to describe, but I would say I'm kind of there's a group of philosophers that I follow that I'm probably closer aligned to called the accelerationists, the left accelerationists. There's the right wing ones too, but the idea is that we need a new left, and I would say that the current new left are kind of mired in looking back to like the 60s and looking at Europe now and saying, okay, that's the ideal to get to, and I think there is some wisdom in that. But I think that I am very much not a skeptic of markets. I'm a huge proponent of markets, but I want them regulated. I want the state to provide healthcare and education and safety nets and all of that. So I'm not like libertarian or something. I do want that. In the top level thing is I am political first, probably. And then I am a sort of business guy second, in a sense. So Plethora is like a project of my further political aims in reality. So like, part of accelerationism is using capitalist tools, right? So like, I fully believe that like Plethora is a good capitalist company because we help our customers and we make money from it, and we can afford to pay our people really well, and it just works. Some businesses, you're almost like not aligned with capitalism, and so it's hard to be profitable and good to the world. Luckily, we're good to the world and profitable, so that's a good place to be. But yeah, it is part of that. And I think that if, one, I don't really want to sell Plethora, so I want it to be independent forever. And I think that if a big industrial company, were to buy us, it would just kill the innovation, right?
How do your investors feel about that? You don't want to exit.
Well, we will exit to the public markets.
Yeah, okay.
And so like that's really my goal. And I tell them all up front. I'm like, okay, this isn't a quick flip them in a couple years company. This is like for the long haul. Like I want to build the next big industrial company. To do that, we have to really think about the future. So I have this sort of chessboard laid out of what that is and how like the industry looks and like how we're going to make it better and like the entire flows of that. So we play a long game that we don't really talk about publicly.
What are the things you can share? Like, what are some of the what are some of the trends that you're especially excited about in manufacturing, and how might other companies out there take advantage of those trends?
Jeez, I mean, I think that one thing that I see is that the digitization of manufacturing still has a lot of bottlenecks in it. If you hear what like GE would tell you, and they'll say things like, oh, we have machines from like the 60s that don't even have sensors or digital technology on them. And like, how do we deal with that? I don't see any companies tackling that. Like if you're a programmer or a couple engineers and you want to like solve a big problem and make money and help a lot of people, like you can help the industrial people figure out how to move into the future, And so there's a lot of opportunity. You see companies like Sight Machine or something who are doing like just basic monitoring tech. Or you see others doing more kind of ERP for small shops. You see people like Rethink doing like new forms of robotics. I don't know if we've really cracked all these nuts yet, but it certainly is needed. The manufacturing world, I mean, a lot of people aren't even like lean and 5S yet, let alone roboticizing and everything else. And so I think there's a lot of opportunities, not even for huge startups, of which there are big opportunities to make startups, but even small consultancies. People who do like automation integrators, the people who like will bring in the robots and make the sort of work cells and everything. Those people are still living in the past. Like when I go to trade shows, I'm like, oh wow, like this hasn't changed since the 80s, like the CAD software looks prettier, but like the shit's still the same. Mm-hmm. So I think there's a lot in the digitalization of manufacturing. Another thing I'm interested in is there's a guy named Brett Victor who I'm a big fan of, and he has a site called worrydream.com. And his ideas are sort of around engineering and learning tools. And I think that right now, programming and CAD systems, they're all caught in paradigms that were developed maybe 40 years ago. So in the CAD world, all CAD systems pretty much are built on what's called like the kernel of CAD that was built like 30 years ago in a time when computers were very different. And there's a lot of limitations. Like you can't even do complex 3D printed things in these CADs. The geometry doesn't work in them. You can't, do new kind of interface techniques because they just don't support them. So to me, we're like limited by some fundamental foundations there. And the same is true in programming. I think the biggest problem with why people can't program is because programmers can already program. So the people who build the tools that we need to make it easier are already good at them. And so it's really hard. Like for me, I want like an artist to be the CEO of a company that has programmers working for them and to develop a language that they like. And when you see that happen, you see things like Arduino. Like Arduino was made at an art school in Italy at the Hebrea school. And they developed an easier, it's still hard, but an easier way. And I think that there's just not been enough exploration in the tool. So I'm really much a tool maker and really want to figure out, like, I think opportunities lie all over the tool field. It's very nascent right now.
I totally agree with you. I mean, I just feel like, especially the 3D printing, for example, it's one of the reasons why I think that it hasn't taken off in the consumer market, because it's impossible to figure out how to go from your idea to if you're not really versed.
Yeah. And it's even hard in the commercial market. So people are able to design basic prototypes like plastic stuff, but the real vision of 3D printing that people like GE are really pushing is really high performance parts that the 3D printed version is better than the traditional version. And to do that, you need very specific design tools. So, my friend has a company called N Topology, and they're making a system that allows you to better take advantage of like lattice structures for heat or thermal or all these other things that you can change how the kind of guts of the material are made, make it out of a foam or a kind of lattice structure. And it lets the performance be, either a lot lighter or stronger or however you're trying to do it. That's not possible with traditional CAD. It's not in the tools. So these new tools will let even the commercial people figure out how to do it. Now you're talking about even further, which is a really exciting thing of like consumers, like how can my parents design things, and have it work? And yeah, I agree. Like I actually, when I make personal projects, I don't like CAD. I still use paper because I think CAD sucks,
I love blue foam and hot wire.
Yeah, sure. And I think there's like the viscerality of those tools is why they're so successful and still used. And if you look at this thing of at first you're an idea in your brain, you're sticky notes on a board thinking of features, and then you're like carving blue foam and cardboard with an X-Acto knife, and then eventually you have to put it in the computer. it's like, well, maybe those original things are fine. Like maybe we're too obsessed with like the actual like tight definitions of things, and the computer should just do that, you know? And that's not what anyone is telling the CAD companies. It's not what their core people want. But I think that this is where full stack comes in. It's like, oh, the CAD companies don't want to do it. Well, then someone should do it, you know? And so that's kind of a thing that I think we'll continue to see. But I think that, hard to get money for this stuff, hard to develop it, you know, like CAD software, very complicated. Most programmers can't write CAD software. It's like we have a bunch of mathematicians who work here who have to do that hardcore heavy lifting. And it's hard.
So why do most programmers can't do CAD software?
They can't do math. Most programmers aren't good at math. Yeah, I mean, really good at math. I mean, they can. I mean, if they can do linear algebra, I would be impressed. Basic algebra, sure, but most programming is just kind of keeping track of all the stuff that's going on the computer, which is not a math problem. You know, you have to. I mean, the most thing they might learn is like big O notation for computational efficiency or something really straightforward like that. But most engineering doesn't require it, so I'm not a fan of even teaching people that much math in general, especially how we teach it today.
Why?
I mean, I hated math growing up, and it was because it was taught so poorly, and I never understood like the global thing. And I remember in CloudFab, when I did it, I was like, you know what, the thing that I'm going to do to analyze these parts, and it was me and another guy, I was like, you know what, it's going to have to be me learning mathematics to do it. And so I was like, okay, I guess I'm going to learn mathematics to do this. And so I had a curriculum that started at a great book called Concepts of Modern Mathematics by Ian Stewart. And that book is sort of like an intro to all these fields where you only need like kind of basic algebra to do it. But you're learning about like group theory and topology and these kind of more high things that you don't even learn if you're an engineer in school. And I think that makes it a lot easier. Also, like we never learn in school things like Mathematica or something where it just does the integral for you. Like the real thing you want as an engineer is just the output. Like you don't really care about the equation.
But you want to understand it though.
Not necessarily. Like most engineers don't understand the Linux kernel fully. Like they don't know what's going on in there. They just use it instrumentally, you know?
Right, and that's where the tools come in.
Yeah, I want a higher abstraction. Like engineers aren't generally solving equations at their desk. There's software that does that for them, right? Like what I want is heavy leverage. I want to be able to say, oh, I need to make an engine. How do I do that? And the thing just does it for you. You know, it leads you through some of the concepts and like shows you where you're wrong and everything else.
So it's almost about asking the questions rather than solving the problem.
Yeah. And I don't know if I would say that engineering school actually teaches you that kind of thinking. I think it's very rote. Like when I was in engineering school, and I kind of quit engineering school because I hated it. And when I was in there, I was like, all we're doing is solving stuff. We're not building anything. And no one really learns. You know, I know that Olin. Olin, yeah. They have an initial part of their program where like one of the first classes is you make a device. Like I think you copy like a consumer device or something, and you learn about all the manufacturing, and you learn about like how to make a full thing. And then it's like, okay, your thing kind of sucks. You're gonna need to know more engineering to refine it. And it's going from the top down, not the bottom up in this way.
I think history should be taught that way too.
Man.
It's like where we are today, how do we get here?
I'm very against how school is right now. It didn't work for me at all. Like I taught myself everything I know. My mom taught me how to read. So school did not teach me anything. I was always trying to get out of it.
Well, this really brings me to the topic that I want to go back to is the whole, all right, we have this vision, your vision of the future, you know, of a lot of abundance, right?
Sure.
Hopefully, how do we get to what are the skills that we need? Because clearly we have a lot of inequality in access to that kind of, right? And a lot of it is a skills gap. I mean, and
mentality gap. So I would say like, who are the most successful people as both, like not even like the 0.001% who are like, the Bill Gates of the world, but like in job titles, you know? And, you know, you can say that the probably most progressive of jobs right now is probably the tech industry in many ways as ascendant. Like now the top companies on like the S&P tech companies, you know, why is that mentality different? And I think one of the things that is so good about the tech community is its metabolism of learning. So the tech company, you know, that employs people who say can learn but don't have the skills right now a lot, I think beats the one where you have people who learned the skills and never learned again. Like you are irrelevant if you haven't continually learned.
Right.
And to me, the entire point of education is it's from Prussia, right? In the late 1800s was when this was made, when we wanted to crank out people who knew math and writing because we needed to employ them in the new industrial stuff that we had. And we needed a lot of kind of cogs in the machine. And now that's not as useful. Like the cogs in the machine are software. So like, how are we going to make a better society is by people who are adaptive, because society is only getting faster. It will never slow down. And if you slow down, you lose, and you lose your competitiveness. And a lot of countries that are in like bad straits, I think a lot of their competitiveness was gone because they didn't want to adapt, you know?
But a lot of people would say, all right, this is Silicon Valley arrogance coming out
Completely,
here. Like,
yeah.
so, great. That's all fine for the top 1% of people that will be the founders of Uber, Plethora,
People
Facebook.
would have said that. People would have said that for reading and writing a couple hundred years ago, when only 1% of people could read and write.
So is there place for people at that level? Right now we have the most educated and most underemployed generation.
Are they truly educated, or have they just been through a lot of school? Because I would actually think it's the latter.
That answer doesn't surprise me.
Well, there are tests that show this, right? That like you test people in the beginning of school and after, and the ability of actually critical thinking has no statistical value of going through school for nearly all majors except a couple of the like kind of logic and math and engineering fields.
So let's say if everybody had that critical thinking
Yeah.
skill, they know how to learn,
Yep.
they have the right attitude. So what does the future look like when everybody has that? Is there space for all of them?
I mean, I don't see how we don't have problems forever. Like, I don't think you just magically solve them. I think that like we're going to be solving disease for a long time. We're going to be solving problems of humans for a long time. I mean, here's one example of like how I think the future of jobs looks that I don't think is talked about enough. Compare the components of GDP by industry, or so aerospace or manufacturing, whatever, and then compare the Maslow's hierarchy of needs and which of those components of GDP are going into which needs. You'll find that like 90% of it is going towards the bottom of the pyramid. Food, things to get you food, and everything else. You're finding very little things about personal fulfillment. You're finding very little about relationships or anything like this. That's the minority of, like people who help you with that are 1% of society maybe. And I actually think that like the skills of being human will get more important over time. We already know that like leadership is not a mathematical function. It's a very human function to be a good leader. And we're going to need leaders forever. And not just at very high levels, but at, like a small line manager or something, very valuable to have good EQ skills that are not taught at all in school, which is insane. They want you to just absorb it from the kind of, Lord of the Flies situation you're presented in high school. But I don't think it really takes. I don't think we actually have those emotional tools. So what I would say is that, no, people will not all be programmers in the future, because programming will turn into a computer program that writes itself. The question is like how humans belong. And so like when I think about this, like there's this arc from, I don't know, I'll just lay out my model for this, which is we began as humans, call it 200 years ago and beyond before that, as toilers. Nearly everyone was like hoeing the earth to produce food, right? Like 90% of us. And then beyond that, we started mechanizing those things into like tractors and everything else. And so we removed toil from most people's daily labor, and they became what I would call controllers, people who manage the machine, So that's where like my grandfather was a machinist. There was a big motor that would move the material out of the way, and then he would control the machine. Then the machines that we have at Plethora, the motors have a computer attached to them, and then you just program it. So people become programmers. So people who are machinists at Plethora and other companies, they program these machines. But Plethora is automating the programming. So then what do they become? They become designers, either of the process itself or the designs we're making. And so that's design. And what is design? It's reconciling the physical world with the human world. It's saying, what do people need and how do they operate, and what's good user experience, and then making an engineered thing to do it in software, hardware, or even a legal system. And so that to me is the future. Is actually, it becomes more human. And all these things that we think of, oh, we're going to code. I don't believe that. Like, I think that, yeah, we'll probably have in the short term more people programming, but I actually think programming will become something like writing, and you won't actually think of it like that. And you won't write code today. Code today is so it's too low level. It's like if you had to write in binary or something.
I remember actually doing
people had
assembly
to,
language.
yeah.
Like, oh, glad I don't have to do that anymore.
Yeah, and it's funny because we got C, which was right above assembly, and then we got interpreted languages like Python, and then we stopped. And we're still there, and C is still used, and it's from like the late 60s, which is crazy. We haven't changed our ways since the 60s, which I think is like endemic of like how programming has failed. But regardless, I think the future is actually more human. So I don't think everyone needs to be adaptive in the way of like learning technical skills. Tech is one thing, and it's a big thing, but it is not even half of the human experience, right? So I think that like a lot of those soft skills are actually going to be the majority of what people do in the deep future.
You're listening to The Art of Manufacturing. Join the conversation on social at We Make It in LA and our Facebook group, makeitinla.org/community. We'll be right back after this break. The Art of Manufacturing podcast is a collaboration with Make It in LA, which is generously supported by organizations like the LA Cleantech Incubator. LACI has a really cool facility in the Arts District of downtown LA filled with energetic startups and nonprofits. They offer cleantech startups flexible office space, epic prototyping labs, and the #1 rated cleantech incubation program in the world. Learn more at makeitinla.org/LACI. We're speaking with Nick Pinkston, the founder of Plethora. He shares his thoughts on manufacturing, automation, and how to start a hardware company. So let's get to some practical things again. So you work with a lot of hardware companies. You were kind of the started the whole meetup craze of hardware meetups and all that. So you deal with a lot of hardware companies. What are your tips on what are hardware companies doing wrong these days?
Oh man, I think it's interesting. Like, first, why do you even want to be a hardware company? That's, I think, a big question everyone should ask. There's a trend that I think is a good one, which is called dematerialization. So you don't have a fax machine. If you want to send it, you send an email. And if you really have to send a fax, there's like a web service that does that for you. You don't need a fax anymore. Can your app have that? Like, too many people are making wearable devices that could just be inside of an iPhone. Why are you making hardware? So the reason to make hardware is when you want to sense or actuate the environment. If anything else, if you just want to have notifications for something, then put it on a phone. If you want it in a very specific location, maybe there's off-the-shelf hardware that will help you. Like, really try to do it so you don't have to make hardware. I think that's the first thing about hardware is like, don't be a hardware dogmatist. Every answer is not a physical object. But if you need one, why do you need it? So I think that beyond that, if you really need something, there are people like sourcing companies that can already help you go to China and look at Alibaba and figure out if you actually need it. Because there's a lot of stuff there, But say you need it. I think one of the problems that people don't do is they don't do market testing early enough. I mean, I think it's always going to be true that if you're making a physical device, you have to have hardware people on your team, but you have to have people who actually understand marketing and product on your team. And there are too many teams that are just engineers who are like, oh, I can build the electronics of this thing. And they understand nothing about what people want and their behavior. And you're going to find that building hardware is way easier than selling it. That's the ticket in building hardware. If you can't build hardware, you should be doing something else and hiring people who can. If you can't build hardware, then you should probably be good at the people part of it. When I was a mentor at, I won't name the accelerator for hardware, ostensibly I was brought in to talk about manufacturing for people, but I ended up talking about how to do pitch decks. That became the thing that's hard. And so I think for every business, it's like hardware isn't that different other than you have to get the thing right the first time, because if you go to production at scale and then you fail to create a good product, you're dead. So that really begs for more prototypes, more pilots, and really good, honest studies of the market and really understanding it. And if you can, producing it small scale first to be able to do it and just baking that into your process. So a lot of people, I think, who are doing a good job, like say something like MakerBot. All the concerns of MakerBot aside, like what they did really smart was that they built, and one thing is it was a high ticket item. So a couple grand, you can do that onshore. And so they did in Brooklyn. I remember going there when it was like 3 people, it was funny. And then they were just putting bolts in the kits, and then they built a thing, and then they built a factory to build a thing. And now they have someone else doing it, but it's still built locally because that's how they can be responsive to the market. For consumer goods that are very low cost, that's when you sort of have to go to China, but it's also where you can be creative in how you go with very small numbers of things. So designing your hardware for pilotability and for flexibility from the very beginning, huge deal. If you do something where it's not updatable later, then someone has an expensive brick that they use. And this happened famously at Quirky, right? Where they shipped like 100,000 units and then they unfortunately got the security certificate wrong. And I don't think it was updatable. So it was like, oh man, like that was, a sad story from this hardware. That's what makes it hard is like, you can't just deploy updates to the server. So I think
unless you're Tesla.
Yeah, it's true.
It's amazing.
But again, high ticket items. So high ticket items you can do in the States because the actual cost of the materials and components is actually significant. And then you can just import that stuff or produce it on machines at scale. The hard thing is that assembly labor and some of that startup labor of a low ticket item, you can't amortize. So it's really hard to do electronics, consumer stuff in the United States. I think there was probably too much consumer hardware. Like in my meetup, I see a lot of consumer stuff that I'm not sure should really exist. And then I don't see very very much industrial stuff. So if I was going into hardware today, I would look at the sort of fields that aren't sexy, you know, look at construction and agriculture and you know, like retail stores, like these kind of things that are just background elements of your daily life. Lots of money goes through there. Lots of pain goes through there. And you can optimize that stuff, but it's not people's everyday experience. People are used to running and wanting fitness trackers. They're used to wondering about, you know, where their dog is.
Well,
like,
here's the
there's all
question:
these
is how do
things.
you then get the people with the experience? You know, most of the, at least this is the myth. Done research in the past actually that has busted that myth. But you know that entrepreneurs, successful entrepreneurs are young, you know, and because they're more disruptive and they have more energy. They don't have the experience. They don't have the kind of experience of agriculture and industrial.
Yeah.
So what's the solution to that?
Yeah, it's interesting. I mean, I think the question is like, if you're starting a company and you're doing it because you're like, I want to start a startup, and you a lot in San Francisco, everyone, you know, your Uber driver wants to have or has a startup, you know, I mean, literally. And when you hear this, like a lot of people want to start a startup because it's cool, and because, you know, there's some like, oh, you're going to get rich or something. But no big company that ever made it was started by someone who just wanted to get rich. Think of Apple. Steve Jobs was not in it for the money at first, right? I mean, later on, I'm sure he was enjoying the money, but all these people loved that stuff. So you have to do what's authentic to you. I think that's the main thing. So like, yeah, the age thing, I don't think is anything other than like a lot of young people don't have a family, so they have a lot easier time taking big risks. So I think it tends towards that. And like, maybe, I don't know, there's like natural energy over time that goes down, but I don't think so. Like Henry Ford started Ford at like 46, and it was his third company after he failed twice. Edison, super old, still inventing, right? Dude was inventing until he died. I don't believe it. I don't think it's that. I think it's really just like people of authenticity and like the love and drive of it that do this. But yeah, I would say don't start a startup if you're just trying to do it. Like find something that's truly authentic to you and beat your head against the wall trying to solve it without doing a company. Because a lot of times you can do that. You can find things that are just products that do this on Alibaba or in some weird corner of the internet and do it that way. And really, if you can't find it, then you know you're onto something. And you find a lot of people who have this problem, and then you really, really look at it. I think people aren't honest enough with themselves. Radical honesty of like your shortcomings, the real dynamics of the market, the real dynamics of the industry of like that you live within. Too many people don't consider the other companies around them and how they're going to get squeezed out by things. Like if you're going to try to make an IoT chip and you're not Intel or Qualcomm or something, you're going to have a bad problem because of all the like kind of licensing of that stuff that goes on and all the kind of collusion in that industry, right? You have to consider all that. And people just are, I think, a little bit naive when they start in doing that. And I think you have to really systemically think about it, but from a place of authenticity of like, you know, this thing. And if you don't know it, I forget who it was, where it was like, I think Howard Hughes worked at an airline when he was still rich just to see what it was like to do it. And there's a lot of people who do that just to gain that authenticity to really see those problems. So I think that's actually an awesome approach. If you want to figure out like what's wrong with agriculture, go to a farm, you know, and understand them. Yeah. And I mean, for me, it was like going to CloudFab. First, I made CloudFab because I was like, oh, I like making stuff myself. Let's make that easier. And then I went to factories, and I had always been obsessed with them, but really getting into the nuts and bolts of how it works. And I was like, wow, I can't believe this is how it works. And I was motivated because I had to make CloudFab work. So I was in a lot of factories, you know.
So that's the opposite of the arrogance. Is actually, wait a minute, I don't know the answer to this.
Yeah.
I'm not going to tell everyone else how to do it. I'm going to actually learn how it's done.
And I think that you can have both too. I mean, humans, we are societies of the mind. And like, you know, you can at one point, you know, like I go to these machine shops and I'm like, whoa, I don't know anything about what these machines do in comparison to the people there. At least I used to say that. And now I'm like, yeah, these people are just totally like I know what they know now. And I think they're wrong still, you know, and maybe that's my own arrogance, you know, we'll have to see.
You've mentioned before about the idea of firing customers. Could tell me about that, because it could be, it's very counterintuitive, but it might also be an interesting perspective for people running their own companies.
Oh man. Yeah. I mean, I think that like firing customers is the sort of freeing up capacity of yourself to do better things. So I tend to find that like a small percentage of customers, and often the ones that don't even pay a lot, like the people who like, they don't want to pay you, they want you to do everything for them. Nope, gone.
We need a Yelp for customers and clients, don't you think?
Someone tried it. I think it was like banned
really?
or something.
Oh,
yeah. But you're right, like almost like a credit score or something, like reverse Better Business Score.
Actually, I would probably do really poorly on that.
Yeah, I mean, I hear you. I mean,
I'm demanding.
Yeah. And it's interesting, right? Like this is why, you know, there's very few manufacturers that have a good net promoter score. It hovers around 20 to 30. Which is kind of like, meh, you know. I mean, they're not Comcast, they're -10, but, you know, not great NPS scores, yeah.
Let's be specific to you, though. Like when, give an example of a time when you've had to.
Yeah, we had a customer that we don't serve, and basically they were extremely demanding with like a lot of little custom stuff and a lot of like do this and then do this and you know, like the manual model of doing all this custom stuff. A lot of people are used to it. I would say that some engineers at places like Apple, they're used to getting what they want from manufacturers because Apple is such a huge thing. Everyone will bend over backwards for this, and then they start a company and they think they can do that to everyone because that's what they were used to at Apple. And it's like, sorry, the reason Apple gets everyone to bend over is because they're going to give them billions of dollars, you know, and that's the only reason you get that. And it doesn't make sense for you as a startup to do this. So, you know, we just were like, nope, we're not going to do it. So deal, you know, and I think that's what it is. And I think that
So how would you apply that to if I were running a company and wanted to figure out how to increase my productivity and effectiveness?
Sure. Yeah, I mean, I think that the basic analysis that a lot of people don't do as like entrepreneurs or even just like regular business owners is actually just like having a list of customers and trying to understand their contribution to your business, and not just from revenue but profit. So if you can actually get the cost of goods sold on them. And so everyone in the sort of VC game talks about like CLTV over CAC. So what that means is customer lifetime value divided by cost of acquisition, and that better be a whole number or higher. So you want like 10x if you're awesome. And even a regular business like a machine shop or something has to be looking at, what am I really getting from this customer? And you'll see some of those are negative. You'll see that you had to acquire them and their cost to serve and retain them is higher than you're actually getting from profit. You fire all of those customers. You know, that's what it is.
And how do you fire them? Do you need to worry about how you fire them?
Well, I think what you do is you raise the prices, or you don't offer the thing that they want. Like, you know, in this case, it's like if someone's coming to me saying, I want a cheap part and I want all these custom things, I'm like, well, here's the price on that. And if they're like, oh, I'm not going to pay it, it's like, okay, well, we're not going to serve you. Done. Like, if they do pay it, cool. You were leaving money on the table and now they're profitable. So a lot of them just raising your prices is fine. I think people are, you know, in manufacturing especially, people don't want to raise their price. It's funny, like we have a really good NPS score at Plethora compared to other manufacturers. And I was surprised. I was like, oh, wow, our service, we have all sorts of bugs still. And there's still tons of things.
So you survey them. You ask,
we do.
Yeah.
We survey every customer. Yeah. And, I was like, yeah, I am, thinking there's all this work we have to do. Right. And they're like, no, like, are you kidding? Like all these other shops where I'm calling them on the phone are really hard to work with. And you guys are easy in comparison. And I was like, okay, that's great. And I think that you don't realize actually that a lot of times those hard customers, they can't get it anywhere else. Like we've had that before where people came to us and we were like, yeah, we're not going to do that except for this really high price. Like, oh, that's high. I'm like, well, sorry, that's what it is. And then they come back a couple days later like, okay, sorry, no one wanted to do it. And it's like, yep, we thought so.
Help us understand a little bit more about what's the cost structure in your business model. So and how does it compare to a normal machine shop?
Our shop is like the major thing that, because we're really similar to a regular machine shop. I mean, we have capital on the floor, we have people who run the machines, and all that's the same. And, we make money when people buy physical objects. So we pay a cost of goods sold on the part and then we sell it for revenue, and the difference is the profit. So it's a very basic, we're not putting ads on the parts or any kind of Web 2.0. But, it's a very traditional business model. The thing that we've done is we've taken the cost of goods sold of a part and the speed of customer interactions with us and really accelerated that. So we make money the same way, except we make a lot more profit because we've modified how COGS is by making this like big technical sort of achievement on how the machines are programmed, how our factory is run, and then how orders are taken. So the two big costs of manufacturers are sort of like on the floor and then upfront in quoting and customer service. So we've made, on the front end, our add-in removes that customer service cost down to a digital, essentially free thing. On the back end, we made all this software to automate the factory. So what's left? It's CapEx, materials, basic overhead, but there's not a lot there. So that's where regular machine shops are really squeezed because they have a lot of humans to do anything, and that's a hard and flexible place to be. It's hard to scale. If you get 50 unique components in a week, they're like, well, I would need like 20 programmers to do that. They can't do that. They can't hire up and down. Well, we have servers to do that. So we have infinite machinists.
What's a typical cost on a part that comes through here?
Call it $200 for unit one of one design. Yeah.
So if you have a $200 part, what percentage is labor on the part? What part of it is other overhead? I'll
say this because we don't super reveal a lot of our COGS, but I'll say that, if $200 part might have $1 of material in it, and it might have a small fraction of that overall cost would be the machine itself. And it's gravy after that.
And let's say I were a traditional machine shop I'm quoting you, what would that look like?
Yeah, I mean, you're going to have, often they would no quote the stuff we take. So we take a lot of people who are like, well, a lot of shops are like, no, we don't want to do this, or you better be making a lot of stuff and we will lose money on this at first to get your longer term business. That's where people are getting it. And so we actually are kind of this people in the market where we actually can do it and we can give a price where we're making good margins on it, and no one else wants that work, especially for the quality of part we have. So we're at this sweet spot of like really fast, very high quality. People remark on the quality, and but still reasonable in price. Like we're not discounters. We're not leaving money on the table. We know we have a good service and we're going to charge for it. But we're also not trying to be crazy expensive either. We want a large amount of people to use it, right?
Tell me about your 16-year-old self and what he would think about you now.
Yeah, it's funny. Whoa. I've changed a lot since I was 16, and then I've stayed very much the same since I was 16. I mean, when I was 16, I was like working on souping up cars in my, like random thing. I was reading a lot of books on science and stuff, and I was building like rockets. I used to make rockets and rocket engines out of like, I went to Agway and got like the chemicals and made my own rocket fuel.
Really?
Yeah. I used to get like 50-pound bags of potassium nitrate and make rocket fuel. Yeah.
You wouldn't get on an airplane now after that.
Yeah, it's funny. I remember going to the store and they're like, why do you need this stuff? And I was like, oh, it's for science. And they're like, okay.
Yeah, that wouldn't fly anymore, I don't think.
I don't think so. Yeah.
I'd like to ask everyone 3 other questions.
Okay.
So one is, what does success for you look like in 5 years? Like, how do you know that you're on the right path? You've been successful.
Yeah. I like to think about when I'm well located and when anyone is, I think there are 3 things to look at. So one of them is your impact to humanity. How many people do you help? How much are you helping them? That's a big thing for me. The second one is how unique are you at doing it? So if you're going to start a company that can have high impact and help a lot of people, but 100 other companies are doing what you're doing, maybe you don't need to exist. Maybe you should do something you're more unique and authentic for. So uniqueness is a big deal because that's how you're making a unique contribution to humanity. And then the third one is personal kind of sanity. If you like this thing so much that you're getting energy from doing it, because startups are hard and they take longer than you think they will take and everything else. So if you are having fun every day, not that there aren't hard things all the time, but net you're having fun, you're unique in what you're doing, and you're making a lot of people in the world better off, I feel like you're doing really well. And that's how I feel at Plethora, where it's like, okay, I think we have this really big lever to move R&D metabolism forward. I don't think there's anyone else doing what we're doing. And I feel like every day, like I get over time, I get more happy as the CEO, which is great.
Wow.
Like a lot of people, they really liked making the product early on, and later when they have to do a lot of strategy and management and stuff like that, they're like less interested, but I actually love that stuff. So I feel like it's all great.
So how will that look like for Plethora in 5 years, you think?
God, it's hard to predict the future, right? But I think for Plethora, I think we've had multiple processes going on in multiple locations around the world, and we're just helping like a significant amount of companies. Like, you push a button and the whole thing comes out. That's the goal of Plethora, really. And if we can do that, I think that hardware will then become as easy as software, and that means that we're going to start seeing a lot more. Software got easy, and we got all these apps, right? Millions of apps. And I think that's coming for hardware too. All these nascent little markets. There might be a market for $1 million here that 2 people in a garage can do every year. And that's awesome for them. And they can't do that because manufacturing is too expensive now. And I want to enable, 1,000 flowers to bloom kind of thing in this market.
So the next question is, in that, pursuing that, what keeps you up at night now? What are you the most anxious about?
So as this is the year of scaling for us, so it's very much like we built this technology and we're in the market, and we are like often tacking out on capacity. So we keep doing more and more stuff. So there's all these, I think there's like 3 throttles. You've got one throttle is how much you can push marketing to get people to come in and even be aware. Then there's like your sales and like how you convert them into customers. And then there's how you actually fulfill the orders in our case to do it. So the factory. And, if I push too hard on the first 2 levers, then the factory gets overwhelmed. And if I push too hard in the factory, I've got a bunch of people sitting out there not doing anything and a lot of cost. So really those operational things are really what I look at now. Like I have my executive team, I have the planning. So it's really just like, okay, like how do we optimize every little thing? And like, it's fun because I get to go around all the teams and I'm not doing like day-to-day work on any particular thing, but I get to optimize every little thing, around. And that's fun for me. And what keeps me up at night is just like, okay, I better make sure those throttles are on the right position, right?
So if there's one thing you wish you had known when you started Plethora that you'd want to share with other entrepreneurs, what would that be?
Oh God. I would say, for us, we should have hired someone who did more HR stuff early. I think that as we grew as a team, it was like we really needed to like understand like how to like make people successful and make sure people feel heard. And I've only worked for myself. Only at small companies. So I've never even seen a department like this. And so I think that was the biggest thing for me is like really having to like I am, my Myers-Briggs is INTJ, meaning I'm pretty bad in the EQ department. And my girlfriend Rose is amazing in that department. So she has taught me a lot over the years of how to do this better. But I think as a tech company, like don't ignore the EQ kind of HR stuff because now we're good on that. But earlier, we had growing pains as we grew very quickly in hiring and we needed to make sure that everyone knew what was going on. And, there's these step functions in management, where it's like you go from 10 people to 30 people in a year or something. And it's like, yeah, that's a big change if you don't have it very, spec'd out. And I think we could have done better.
Something happens around 20, 24 employees, I think, where it changes the culture.
Yeah. Yeah. At this point, it's like, new people start and it takes them a while to know everyone's name, like that's hard.
How many people do you have now?
We are 47.
Wow. Yeah.
So, yeah, I know. It's kind of
crazy. Do you know everyone's name?
Oh, of course. Come on. Yeah. I know everyone and what they do. And,
you interview everybody?
Oh, yeah, totally.
Yeah. So you can still do that.
I can still do that. And, the worst is when I have to do a phone call. Sometimes they don't have a chance to come in, but I really try to interview everyone. I think that this year I'll still be able to do it. Next year might be challenging. But, yeah, I think that I know that at SpaceX or Tesla, Elon interviewed up to maybe 2,000 people for at least 15 or 30 minutes or something. And I looked at that and I was like, whoa, that's crazy. But I would be interested to sort of see how far we can push it. Because it is like one of the most important things. Like the human element, I think, is the most important. It's like the older I get, I feel like the more it's like all the technology is easy as long as you have the right people and they're properly motivated and incented. Like that's the entire thing. All those books on leadership that I used to laugh at when I was like 19. Now I'm like, I need to learn all of that stuff,
And learning too. They need to be learning, right?
Yeah, completely. Yeah.
So it's not just hiring the right person.
Indeed. Hopefully if you hire the right person, then they can help learn themselves. But we have a lot of programs at Plethora for how to learn. Our industry is hard. It's weird. If you're at Airbnb, well, everyone's taken a vacation before, maybe, but almost no one has seen the inside of a factory. So we have a lot of stuff of like how to get people to know even what this is. And, we can't hire salespeople who just know this stuff. It's very hard. So we have to train them a lot.
Awesome. It's a really neat facility, really amazing vision. And it's always really fun to chat with you.
Totally. Yeah. I'm glad we could do this. Thanks for having me.
Whew. My discussion with Nick leaves me really pondering a few things. First, the role of humans and technology in progress. There's no doubt that automation is replacing humans with machines at a rapid pace, and there's a fear that it will hurt people in lower-skilled jobs. But at the same time, better tools might make the design and manufacturing process more accessible to more people. Experts are usually the first to dismiss an idea of making their jobs easier or more accessible. Maybe they just don't see the value because they're too close to it. I remember how at my first company, Stylus Innovation, we had a product idea and we surveyed 400 computer telephony experts about our new idea for an easy-to-use development tool for Windows. All but maybe 4 said it was the stupidest idea they'd ever heard. We built it anyway, and within 18 months, our little startup blew all the competition out of the water, even surpassing Intel's sales for their development tool. So how did this happen? Because the experts knew too much. Or maybe they were threatened? So, should a designer need to know everything about manufacturability or finite element analysis or material science to make something? My engineering brain says yes, but then my design brain says you shouldn't have to be an expert to be creative. In fact, you're better off if you're not. I think the key will be to find ways that humans and machines can collaborate so people are empowered to fulfill their greatest potential. Second, I was struck by Nick's stark comparisons between the Midwest and Silicon Valley. How do you feel about his descriptions? I'm really concerned about the widening gulf, and I wonder, is there a way to spread the wealth while honoring the different cultures across the country? It seems that one of the key elements to making this work is reforming education. Everything from investing to vocational schools, to emphasizing leadership and design skills, to teaching people how to keep learning throughout their careers. Yet the pace of change has accelerated so much that we'll likely have a lot of instability in the near future while we figure things out. And finally, it was fun to hear Nick's tips for starting a hardware business. His first piece of advice, don't start a hardware company, at least if you don't have to. If you're in LA next week and enjoyed this topic, I hope you'll join us at the premiere of a new short documentary about automation next Tuesday, April 18th. The film is called Before the Bridge and was produced by 72U. I'll be moderating a brief discussion after the screening. For more information, visit makeitinla.org/events. So what do you think? We can't deny automation and artificial intelligence are here to stay. What should we do to harness technology and innovation for good? Time to wrap it up for The Art of Manufacturing. Tune in next Thursday when we speak with Yvka Adam of Iconery. She's mashing up design, 3D printing, e-commerce, and influencers to create a new kind of jewelry company. Visit makeitinla.org for show notes and to stay in the loop about events, news, and resources. To chat with other like-minded manufacturing entrepreneurs, join our Facebook discussion group at makeitinla.org/community. Never miss an episode. Subscribe on iTunes, Google Play Music, or your favorite player. And if you like the show, do us a big favor and leave us a review. Or send us a message with feedback and ideas on Twitter at WeMakeItInLA. This podcast is produced by At Large and Dangerous in collaboration with the Make It in LA initiative and other partners. A big shout out to Peter Brandenburg, the producer and audio engineer, and our content coordinator, Heidi Carrion. Thanks for listening to The Art of Manufacturing. I'm Z Holly, and remember, don't just make it, make it.